Hey everyone, welcome back. So in this video, we are going to understand today contest problem from the daily series, right? So let's understand what the question is saying that. So the question is saying that number of subsequences that satisfy the given sum condition. Okay, it means we have given two things. We have given nums and target. We have given. You can see in the example also, right? We have given nums and target. What is nums? Nums is an array and target is a variable, or you can say integer, and we have to return the number of non-empty subsequence of nums, means of this array. We have to find all the subsequences which is non-empty that satisfy a condition. What is the condition? Means the sum of minimum and maximum element on its is less than equal to target. Okay, so if the answer is larger, we'll take the modulo, right? Just think that we have given this array, right? 3, 5, 6 and 7, right? This array we have given, okay? And we know the possible subsequences can be possible with the, this is, we cannot, you know what is the subsequences, right? The subsequences that if we delete any of this element, right, with or without, the all the subsequences will be the combination of the element that preserve the order. Let's suppose we call it 3, right? There can be 3 and 5. So this is a subsequence. 3 and 5 is the subsequence, but you cannot take 5 and 3 because the subsequence order is failing here, right? So this is not valid. We have already seen in the couple of videos in this week, right? If you are regular on the Excel funda, you know how to implement the subsequences related to the problem. Okay, because we have seen almost a week or more than a week, we have seen so many problems in the subsequences. Okay, so there are the other possible subsequences can be what? 3, 6, 3, 7, and we can take more like 3, 5, 6 we can take, right? And many more. The other possibilities are there, right? So in which, let's suppose I'll take the very first one, right? 3, 1, right? What is the minimum and maximum in these subsequences? So in this minimum is 3, maximum is what? 3, correct? Because there is only one element, so mean and maximum both are at the same position, right? If we'll do plus, means if you want to do the sum is what? 3 plus 3, mean and max plus, what will come? It will come what? 6, and 6 is less than equal to target. What is target? Target is 9, so it's true, correct? And that is why the condition satisfy this 3 plus 3, right? The mean value and the max value of this one, right? So we have taken one subsequences here. Similarly, we'll take 2, 3 and 4, right? So total count is coming 4. Understand? So let me clean it. So if we understand this problem, right? So if you want to approach this problem, what we need to do? We have to find all the subsequences, right? And then we'll check if its sum is the in the each subsequences there should be a mean and there should be a max, right? If it is non-empty, if there is at least one element should be there, so mean and max will be same. So for that we can take 3. If more than one element is there, means there should be, obviously there will be one mean and there will be max, right? And so in each cases you will get mean and max. You just do the plus and check if it is less than target, include as a count, right? Count number of count, right? How many subsequences are there, right? We have to return it. So you can take it and you can return it. That is your brute force approach that you will do, right? Means the first of all, the brute force approach, what you will do, you will find all the subsequences. You will find then mean and max. You will iterate over the subsequences and you will find the mean and max, correct? And then you will do the sum. You will check the sum is less than equal to the target. If it is less than equal to target, we'll so count plus plus, correct? If count plus plus, if in the final we will return this count, will return it, correct? Understand? Now understand, there is one possibility that what we can do, we have given this sequence, right? There is possible that there is another nums we have also given 3, 3, 6, 8. let's suppose this 3368 we have given, right? Is this sorted or not sorted? How? The question never says that it is sorted or not sorted, right? It means if we'll sort this array, right? So if we will sort the array, right, in this problem, right? So to make it easier to find the valid subsequences using two pointers algorithm, it will become easy, right? You know the two pointers algorithm, right? There will two pointers will be there. There is a left will be there, another will be right over the an array, correct? So we will get a certain window, right, from here to here. Let's suppose from here to here, whatever you want, you can get the window of the you can get the window, right? You can say. So in the two pointer algorithm, if we will sort this array, right, so what will become easier? It will become easier to find the valid subsequences, right? Because if we'll find all the times, or we will generate all the subsequences, right, it will be lengthy process, right? And it will take more time, more time consuming, right? So better than we'll sort this array, right? And what you will get, you can get the valid subsequences, right? So why we want to do sorting, right? So we want to count non-empty subsequences, right? If we want to find the non-empty subsequences, right, we want to count how many non-empty subsequences are there. Let's suppose if we will have what, mean plus max, right, of each subsequences, is it less than or equal to target? So this is called your what, the non-empty subsequences of nums. Okay, so if you define, if you know the let's suppose we will take two pointer algorithm, and you will find the mean and max, right, in a certain window. That certain window is nothing but a subsequence, and if there will have minimum and maximum elements, so just you will take the condition it is less than or equal to target. It means this subsequences is a what, valid subsequences, right? And so we will include into the result. So just will increase the count, right? So this is a simple way to implement it, right? So you know, if we found the subsequences, we can find the minimum and the maximum, means the smallest and the largest element, and we'll just check the target. I hope you understand. So what is our intuition, right? Let's understand. Okay, so very first step to what we will do, first we'll sort the array, right? First we need to sort the array. Okay, so once you will sort the array, we can use two pointers, right, left and right. Use now what, two pointers. Let's suppose call left and right, right? So the left will be at start and right we will at the end, right, of the array, correct? You know how to find the two pointer algorithm, right? Start will here and end will be at here, correct? Now just we will check if the element, let's suppose for this element 3 we have, 5 we have, 6 we have, 7 we have, right? And let's suppose we'll take one element, 8 will we have, right? So if we will check what, nums at what, left, means start, what we have, nums at left plus nums at right. So you know this array is already sorted, right? Means the nums, the starting index should be the smallest one, right? And the right index should be at what, at the largest element, we can say that, correct? If this is a sum, means nums at left, nums at right, means this is the smallest element, we can say, and this is the largest element for this window, for the current window, we can say, for the current window. Is it true or not? This is true, correct? So if I will say, if this is correct, right, then what we should do, we'll just check less than equal to target. If this condition, if this condition is true, it means what, we have a valid subsequences, right? And we can form the valid subsequences, right? So we can take the, you can say what, we can find all the valid subsequences from this window, understand? So we can pick it the num set left and num set right, and we can find all the subsequences, means any subset of the element that we have, that we can get and we can write. So just we need to do what, left will do plus plus, right, and right will be at the same position, right. We just will do what, how we will find the subsequences, we will do left plus 1, right. So left plus 1, if we will increase, right, and right will be at the same position, right, means from the array. So just we will increase from here to here, right. It means if we'll keep upgrading the left plus plus, you will find all the valid subsequences, right, means the subset of elements, right. So there is a, what are the possibilities are there? If you understand the formula is very easy, right. 2 to the power what will take left minus right. This is a formula to find the all the subsequences, right. 2 to the power left, right minus sorry, right minus left. I think right minus left, because right is bigger, right, and a small is this one. We can say right minus left. Which one is bigger, that we will take, right. So 2 to the power this we can take, understand. So these are 2 to the power right minus left subsequences will be there. And then what we need to do, just keep moving the left ahead forward, and if the condition not satisfy, just move what, right rightward, we can say. Okay, it's very easy. Now understand, if we will use this technique, what will happen. So very first step, if you observe what we have taken, sorting. So sorting will take O of n log n, correct. We know the binary sort, binary sorting or any other sorting, right, simple sorting, still it will take what, O n log n. So mostly the best log sorting is taking n log n, right. Then we will use 2 pointers algorithm, where we'll use right and left, right. So for the 2 pointers algorithm, we'll go for all the elements to track, right. So it will take what, O of n, correct. So if we'll pre-compute this power, what will come for all the element, O of n, understand. Just do plus, you will get the time complexity, correct. Now understand why this is coming right 2 to the power right minus left. So what we need to do, yeah, just think that, let's understand. Okay, just think that we have given a subset, right. Let's suppose we have one of the subset from here. Let's take this subset, right. We'll take 3, 5 and 6, right. So from this subset, right, what are these elements are there, 3 elements are there, right, means free we have here, right, 3 elements we have. So if the choices we have, let's suppose we left is at where, 3, and right is at where, 6, right. So if the 3 we have one element, right, so what is the choices are there. So either it will select 3 or 5 in the very first, right, or it will select itself 3, the minimum that we can do, right, if 3 is fixed. Let's suppose if 3 is fixed, because we are talking about the fixed. If 3 is fixed, means the position we are talking about, this position is fixed. So from 3 we'll go what, either we'll choose 3 or we'll choose next is 5, 3, 5, right. Next the choice is what, from 3, 5 if we have selected, right. So there is one chance that we can select what, 3, 5 and 6, correct. Then another combination is there, what, we can take 3 and 5 itself, as we have taken this one, right, itself, right. So these are the combinations are there. So if you count the, we can say what are the total counts are there, right, just count 1, 2, 3 and 4, means for when 3 is fixed, in the subset choices, right, it means we are getting what, total 4 subsequences we are getting, correct. It means 2 to the power 2, and it was coming what? 4. Understand? So left is at where? 0. Right is at where? 2. Just you take what? Right minus left. Right is 2, left is 0. 2 to the power 2, it become what? 4. Understand? Similarly, you just need to find the window and you will get all the number of subsequences that you have, right? If once you have the number of subsequences, you will find the data. So if in this case, let's suppose for itself, it was at 0. It was where? 1, 2, and 3, right? So the possibility is you can find the each subsequences like this, right? And you will check the, you know, the target, right? So based on the target, you will find the what? The possible subsequences, and there you can check all the possible subsequences. What are the possible subsequences there? Similarly, we have found like this, you can find others. Okay, so let's understand the code, then you will understand the, we'll go through the dry run. So let's understand the code. Okay, so in the very first step, what we need to do, we have to define the mode, because if the result is big, we have to take the mode low, right? Let me zoom a little bit more. So what we need to do, first of all, we'll define the mode, right? So we need to declare this mode, because if the result is coming bigger one, right? So we have to avoid the overflow when the result becomes larger, right? So when the result become larger, right, it can overflow, right? And so we need to define the mode, right? As per the question is also saying that, right? Now what we need to do, we have given two things, we have given nums, we have given, and targets we have given, right? Means the nums array we have given, right, and the target we have given. So in the very first step, what we should do, we will sort this array, right? So to sort this, right, what we need to do, array dot sort we will do, right, and we'll pass the nums. So this is the very first step that we will do, right? Now what we should do, we will pre-compute the power up to nums length, right? So let's suppose if we'll take here array like what, we can take array 3, and we can take 5, they can take 6, and then 7. This was the first we have given, right? And another it was given what, 9 was given, right, as a target, right? So we have given nums, we have given this, and target given 9, correct? So if we will sort this array will get sorted itself, right? So this is sorted one, so no need to show what is the sorted. So we'll call it same, right? It is sorted. So we will try run this example. So I'm using this as well. Okay, so in the very first step, we'll do the sorting, right? So sorting, if you'll do the sorting, you will have the exact pairs of, you can say, mean and max, right? So that we can use 2-point algorithm to find the valid mean and max pairs, right? Means the correct window we will get, right? Okay, so now what we should do, we should check the pre-compute power up to nums dot length, right? So we have seen why we have to do, because for a valid left and right pair, we can form up to 2 to the power right minus left subsequences, right? And for that, very first you will get the length, right, n equal to, if we'll take from here, what will come, n equal to length is what, 4. You will get the length is nothing but 4, correct? So now we'll take the power of this, means we will have the same array, but this array will be blank, right, for itself. Let's suppose we'll call this array, and this array will be blank, correct? So there will be no element will be there, like this element is blank, okay, of the power. Now power at 0, if we will assign as a 1, right? So here when we'll come here, power at 0 will define, let's put at a 1, right? So you have assigned power of 0, that you have element what, like this one element we have assigned it, right? So when we'll have power at 0, power at 1, it means what, if power of 0 we will take, means if we'll take it means what, 2 to, you know, the 2 to the power what, why we have done it. So 2 to the power, if we'll take 0, right? It will be equal to 1. Understand? And so if the non-empty, if we are taking the empty, it means by default there will be one subsequence, right? And for that pre-computing, we are pre-computing the power of 2 up to this length. So we'll take initial value 2 to the power 0 is 1, correct? And then we'll prepare 2 to the power I mod, right? 2 to the power I mod. How we are getting that? You can get, you have to 2 to the power 0 is nothing but what? I. Okay, so I we have taken already 0, so we'll start from what? 0 to n. Understand why we are doing that? 2 to the power, you can say I, and then we will take what? The mod we have, that we will take. Understand? And for that, what we need to do, we have already taken 0, I equal to 0, so value is already set, power at 0 we have set. Now we'll check for all the others power, means these are the rest of the element. How we are getting to, how we are going to do? Just make a loop, take power of I, power at element I minus 1, part of the previous element is there, that we will take and will multiply by 2, and you will get the mod element. You know, each power increment means just we need to what? The previous value, and that you will multiply 2, correct? So let's suppose we'll talk about 2 to the power 2, right? It means what? 2 to the power 2 means what? 2 to the power 1, let's suppose. So 2 to the power 0, and you will multiply that 2, means 1 into 2, it come what? 2. Understand? Then let's suppose we'll go for what? 2 to the power 2. So 2 to the power 2 is the previous value is what? 2, and you multiply 2. What it will come? 2 to the power 2 is 4. Like that we will multiply and we will get the value. If it will become bigger one, right, just we take the mod, right? So we have to take the mod for each power, so it will become what? It will not exceed the 10 to the power 9 something, right? 10 to the power 7, it will not exceed this element. Okay, so like that you have to pre-compute all the values, right? So that you can find the valid left and right pairs, and we can compute the number of subsequences that can be formed by these things, right? So it is easy, right? I don't think it is very complicated. It is very easy problem, right? Just need to sort it and you have to pre-compute this value. After that we will initialize 2 pointer, the left and the right. Left will start from where? At index 0, and right will be at n minus 1 on the given array. So this result will increment as a count. So this is nothing but our count, so we'll increase this count 0 0, right? So we'll check if left is less than equal to right. You know the 2 pointer technique, right? In the 2 pointer technique, just will increase left plus plus and will reduce minus minus, right? So that what will happen? Give me one second. We know the 2 pointers algorithm, right? What we need to do, we need to create an, let's suppose an array, right? Like this. So this is your left and this is your right. So if left is here and right is here, so left will move this way and right will move this way, correct? Means at certain position, when left is plus plus, left will come here next time, then right will come here. So at certain position, let's suppose a 5 element is there, okay? So at certain position, that is the middle, right? At middle, what will happen? The left and right will be at the same position. Which position? This position, right? And then we have to stop it, right? Until left is less than equal to right. Till that we will run this loop. Other than we'll stop it, means it will go till the half of the element, right? And each time the left is what? At mean, and right is at what? Max, right? There's many possibilities there. Okay, now what we need to do, so we will define left, right, and this is nothing but your count, correct? Once count is incremented, we'll return it. How we'll get the count? You know, just after satisfying this condition, if condition, you will check if current, mean and max is less than target, it's a valid range, right? means nums at left, nums at right, means some element. Let's suppose we had what, we have taken what, 2 3 something, right? 3, yeah, 3 5, let's suppose 6 and 7 are there. Okay, this was not there. So let's suppose left is here, right is here, and left is here. Okay, so 3 plus 7, is it valid? No. 3 plus 7, if we'll take, it become 10, which is not less than equal to what, 9. It is not less than equal to. It means what we will do, will decrement what, our next pair, that is 6. So 3 plus 6, valid? Yes, it is less than equal to 9. So we'll take this range. So this window we will take, not the 7 one. Understand what we have taken? We have taken this pair and we have discarded this pair. Understand? So this window will be our the greatest window. Okay, after the smallest window will come smallest, right? Just don't think multiple windows are there in which this is the largest window. Okay, so this is your left and this is your right. Understand? So what you need to do, just take what, left, nums at left and nums at right. You will do what, left, you will just do what, select the target and you will find this, right? I know you know the previous result, and this is the power of right minus left, means from here to here. If you need to find, you know how to find, right? 2 to the power what, left is what, at 0 1 2, left at 0 and right is at 2. 2 minus 0 is 2 to the power 2, it will come what, 4. Understand? And the previous, what is the previous result? Previous result what, 0. So total will come what, 4. So the result is 4. Okay, so we'll keep moving that, you will get the everything. Understand? If not, you will go to the right minus that we have seen in the very previous one. Okay, otherwise we'll increase the left. The next window is this window, so left will be here and right will remain here, right? Because we are doing left plus plus. Once everything is done, just need to what we'll need to do, will increase the count and you will return the count. Okay, because left we are getting plus plus at here, right? And you will return the result. I hope you understand. If you have any doubt, please ping me in the comment box. Thank you guys, thank you for watching this video, and let me know if you have any doubt. Okay, and give us support, thumbs up in your preparation journey, right? Give Expert Funda helping hand for your preparation, your journey, and please support Expert Funda by subscribing and liking this video. Thank you guys, thank you for watching this video.